In example 3 and example 4 for that matter, we're going to go over some relatively basic vector problems. They get a little more complicated than this. We'll save that for a later lesson. For now, let's just read through this word problem, this quasi real life example, and we'll see if we can find the answer. So it says for 1 hour, you travel east in your car 100 kilometers, then travel south 200 kilometers. We're asked to calculate the magnitude and direction of our displacement. So if we take a look at a coordinate plane, traveling east by 100 kilometers, we could represent that here. So we're going to travel east this direction. And then we're going to go, we're going to travel south by 200. So let's see, that might be about right in there. So that would be negative 100, negative 200. Of course, south would be down in this case, in that direction. So here is going to be your pathway, and you've ended up here. And our task is actually going to be to find the direction and magnitude of this vector. So that represents the vector from where you started. Here's your initial point right here at the origin, and then where you ended up, which is the terminal point right here. To do that, we're going to just break this down to the x and y components, which happen to be 100 and negative 200. If you wanted to represent this vector, you would represent this vector as 100 comma negative 200. To calculate the magnitude of this vector, and let's just name this vector v. So to calculate the magnitude of vector v, we would represent that just like this. We're going to take the square root of 100 squared plus negative 200 squared. Or in this case, you can just use the positive value because when we're finding distance, we're just using positive values. So that winds up being, let's see here, we'll do 100 squared would be 10,000. And we're going to do 200 or negative 200 squared. So that would be 40,000. See, we can sneak that in the paper there. So that's, oh gosh, 50,000, which is the same as 10,000 times 5. And the square root of 10,000 is 100, and the 5 needs to stay underneath. If you wanted to represent this as a decimal, that would be approximately 223, and you just type in 100 times root 5 or the square root of 50,000 in your calculator, either way, be 223.6. The unit for this here is distance. That's what our magnitude is here. So we can use kilometers and keep that unit in there. Okay, so there's your magnitude. Now we're asked to actually find the direction as well. So for the direction, we're going to use the inverse tangent. And the inverse tangent is always opposite over adjacent, or on the inside here, or y over x. So if we type that in our calculator, let me just try that real quick. You'll do second tangent in the calculator, negative 200. Important to have that negative sign in there, divided by 100. And you're going to get theta to be about negative 63 degrees. You can just add 360 to that if you want to find something that's between 0 and 360. So you could do plus 360. And that would give you an approximate value of, let's see here, just type that in the calculator, and we've got 297 degrees. So that represents this right here on our diagram. Those are the last two pieces here for example 3, and we'll do example 4 for the next one.